Hello and welcome back students to the next module where we are still doing the sums based on enthalpy of physical changes. Let's take the sum. Sum says enthalpy of fusion of ice is 6.05 kilojoule per mole. The enthalpy of vaporization of water is 43.7 kilojoule per mole. What is the enthalpy of sublimation of ice? So let's quickly write the given data. Enthalpy of fusion is represented as delta H of FUS. That means the value is 6.05 kilojoule per mole. The enthalpy of vaporization represented as delta H of VAP, that is vaporization, value is 43.7 kilojoule per mole. And we have been told to calculate the enthalpy of sublimation, that is delta H of sub, that is sublimation. And the formula of sublimation is very simple, that is fusion plus vaporization. Both the values are given, so the sum is very simple. We have to just add both the values and the answer is 49.75 kilojoule per mole. So let's take the MCQs based on that concept. The first question says carbon plus oxygen is giving you carbon dioxide and the delta H value is minus X. And for the second reaction, the delta H value is minus Y. And 4 options have been given and we have to calculate the enthalpy of formation of carbon monoxide. Now remember students, we have been told to calculate the enthalpy of formation of 1 mole of carbon monoxide. So the required reaction will become as carbon plus half oxygen will give you carbon monoxide. Now this is what the required equation which we have to calculate. So we want first is carbon on the reactant side. And if you see the equation number 1, it's very simple. We have to directly take equation number 1 and the delta H value will be also taken directly. Now what we want is only half oxygen, but we have already got 1 complete oxygen. So I guess there will be a little dicey situation that what to do. So let's go on to the third compound, that is third component which we want, that is carbon monoxide, but we want only 1 mole. If you see the second equation carefully, we want carbon monoxide on the product side, but carbon monoxide is present in the given data on the reactant side. So we have to reverse equation, but simply reversing will not suffice the equation. Why? Because we want only 1 carbon monoxide. That means we have to reverse and divide the equation by 2. So reversing equation 2 and dividing by 2, we get the answer as 1 mole of carbon dioxide is giving you 1 mole of carbon monoxide plus half oxygen, and the delta H value will be also reversed. At the same time, it will be divided by 2. So the value become as Y by 2. If you check the data carefully, in the given equation, carbon dioxide is present on the reactant side as well as on the side. So carbon dioxide gets cancelled. The half oxygen is present on the product side. If it goes on that side, it becomes as minus half oxygen. And from that 1 complete oxygen, if we subtract this minus half oxygen, we are left with only half oxygen which is there. That means we got our given data which is there. That means simple minus X plus Y by 2 will suffice the equation. But there is no option with respect to that. So if we take the LCM, the value will be minus 2x plus y by 2. Rearranging the terms, we will get the answer as y minus 2x by 2, and that is what is correct option, that is option B. This is how the sum has to be solved. Let's take the second question. Based on the following thermochemical equations, 3 equations have been given. Calculate the value of x, and if you see the fourth equation, in that the delta H value of x we have to calculate. So what we want is carbon solid on the reactant side, oxygen gas on the reactant side, and carbon dioxide on the gaseous side. If you see in the given data, carbon is already present in the reactant side. For one particular oxygen which is there, now there are 2 equations. In the second equation also there is half oxygen. In the third equation also there is half oxygen. So for let's time being, keep aside oxygen. The third ingredient which we want is carbon dioxide on the product side, and carbon dioxide on the product side we have directly in the equation number 2. That means at least we have to add equation 1 and 2. If we add equation 1 and 2, in the reactant side we already got half oxygen. If we just add equation 1 and 2, and if we add directly equation 3, don't you think half oxygen plus half oxygen will give me 1 oxygen? And if you see the remaining terms, that is H2O is getting cancelled on the opposite side of the arrow. That means H2O is getting cancelled. If you see carbon monoxide, it is also getting cancelled on the equations which are present on the opposite side. The hydrogen atom is also getting cancelled on the opposite side which is there. That means simply add all the equations and we'll get the answer which is there. So simply plus and minus doing that equation, we'll get the value of x, and the value of x will be minus 393 kilojoule per. This is how we have to do the sum. We'll meet in the next module. Till that time, thank you.